All right, so we were working on science. Oh, that needs to go away. Science landforms on Earth's surface, okay? So you need to have opened lesson 4A. And first we're going to watch 2 YouTube videos, okay? Sophie.
The idea that our planet's continents drift around the globe, periodically belonging together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on, unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental landmasses, the thinner of the 2 plates bends and slides under the other. As the edge of the seafloor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
Okay, that's one video. Yes, Thomas? What if the tectonic... If they didn't move slowly, then they wouldn't move? If they stopped moving, I don't know what would happen. That is a scientific theory. Quickly. Okay, Ledger. Quickly. Pull up your masks. Okay, let's watch the next one. Ready? Mohammed.
Volcanism stops seafloor.
The ground beneath our feet is always moving. We don't feel this often, but we can see the results of the movement almost everywhere. The Earth's crust is what moves. Our planet's outer shell. It is not one piece, but instead is made of individual puzzle pieces, plates. They were all part of a continent that broke up over 200 million years ago. Since then, it hasn't stopped moving. This is called tectonics. Plates move slowly, as fast as growing fingernails. Continental plates form the land the continents are on. Plates that are covered with water are called oceanic plates. They are thinner and the rock is heavier. continental plates collide, the folds can pile up and create huge mountain ranges up to 8 kilometers high. An oceanic plate pushes itself under a continental one. It disappears into the Earth's hot mantle, creating an ocean trench up to 8 kilometers deep. On its way down into the mantle, the oceanic plate melts. But the liquid magma can return to the surface at another place. A volcano is born. When two oceanic plates move apart, the seam is called an ocean ridge. Magma from inside the Earth escapes here. This drives the plates further apart and makes them grow. Plates that glide past each other can get tangled up and stick. When they separate, the Earth shakes. Earthquakes show our planet is anything but a calm place.
Okay. Okay, now let's go back to Google Slides. Okay, everybody's mask needs to be on because your treat should be over. Elian, tapa boca. Elian, tapa boca. Thank you. Mohammed, pull your mask up, please. Huh? Thank you. Okay, what do you need to say, Ariana?
Can I answer the question of what if they stopped moving?
When we get there. Okay. All right, ready? What evidence is there to support the idea that plates collide and build mountain ranges? Okay. Dylan, I'm over here. So we need to focus on that. Sophie and Merle. Okay, so everybody should be on this slide now. Noah, do you have your Chromebook? Log in, please. Thank you. Okay, on this slide, so we need to start typing. So think back to our last science lesson. So that was on Tuesday. What do you think about how moving plates cause Earth's surface to build up? So what do you think about that?
It's just like how we did with the graham crackers.
Just like how we did with the graham crackers?
Mm-hmm.
Okay. What happened with the graham crackers? So what do you think about the moving plates, Thomas?
The moving plates, if they grew long enough, they could start to make
They can build mountains? Okay. So the moving plates can build mountains. Elian typing? Dylan writing down? The moving plates can build mountains. So what do you think about how moving plates cause Earth's surface to build up? The moving plates can build mountains by pushing on each other. Do we want to add that? So let's say the moving plates can build mountains by pushing on each other. Period.
No one needs it. Yeah, it's fine.
Okay? So, but how do we know if this is true or not? How do we know that? What do you think? It's okay if you have like no idea, but you can make a guess. Ledger?
It's probably true because of like scientists and like what do you call them? They're in space.
Astronauts?
And no. The satellites.
Oh, okay. By pictures from satellites?
Can I get that one?
I don't know if you can type this in. But pictures.
Oh yeah.
Can you? Okay. By pictures from satellites.
Can I phone that one?
Quick repeat. Ariana, what did you want to say?
For some reason, it shows the answers for me on every slide. Is that supposed to happen?
Where?
So on this one, it shows that, and then oh yeah, yeah, it says that one too.
Well, nobody can fail. Okay. Last question on this slide. What evidence do we have that supports this idea? Where did we get the evidence from?
Oh, that's supposed to have two L's. It's supposed to have two L's.
Oh, yeah, she's right.
No, it's not. I put it
Okay,
in another L.
Ledger, what do you need to say?
To prove it because it said it in the Bible.
Okay. By the, what is the YouTube video called? It is called Tectonic Plates, Da Vinci TV Tectonic Plates YouTube video. Okay, let me go back. Was it that one? Oh, I think it was this one. I don't remember. Okay, by the Da Vinci / Tectonic Plates YouTube. Oh, YouTube should be capitalized. Video. Period. Okay. While you're typing that in, I'm going to give you some water. Got it on this?
Front row has COVID.
Okay, that's the bottom.
Hopefully not, though.
That's back row. It's not letting me go to the bottom.
Okay, ready?
Yeah.
Good, Elian. Okay, I'll give you 3 more seconds. The rest of you start looking at the pictures on the next slide. Start looking at the pictures, Dylan. Ledger, start looking at the picture. Okay, all right. Good job. Next. Let's look at these 4 pictures, okay? No, it does not.
What happened to the cookies?
As a step toward getting some evidence, we're going to look at yet another way of showing or representing Earth's tectonic plates. So what models have we used so far? Raise your hand. Dylan?
They move slow and they fork slow.
Yes, so which models have we used to show that? To test that? Graham crackers, Ledger?
And the egg.
Ledger?
Eggshell,
The-
hands, and the oil for
The eggshell,
and the
Noah?
crackers we push together. Hands.
our hands. Anything else? Dylan?
Oil on the water.
A buoy on the water?
Oil.
Oil on the water? Yes, the oil on the water. Oh, I'm glad you remembered that.
Good girl. You get bonus points for remembering a bit YouTube video. I remember.
Okay, anything else? Good. Okay, next one. Ready? So what did each of these models or representations show us about the Earth's crust? So the eggshell showed us what? Ledger?
The Earth's crust was like tiny little puzzle pieces.
Okay, the Earth's capital E. Oh. The Earth's crust typing is like puzzle pieces. Period. Got it? Good, Dylan. Good, Sophie. Good, Marley. Good, Thomas. Okay, the floating wood. So that was the oil and water. Ledger?
So when the like I don't know what it was, but they would they would fall to the bottom, and then when they got to like the hot part, they would come back up, and it would just constantly do that.
Okay, the heat causes the core to move around and moves tectonic plates. Period. Okay. Our hands. So what did the hands show us?
Tectonic plates moving. Like how the tectonic plates move.
Okay, so how tectonic can shift / move in different directions. Let's be specific, okay?
Who's talking about? I have a problem.
In different directions, period.
Who's talking about? My Chromebook is about to die.
I can give you a paper.
I don't want to do
You
paper. Paper is easy. You just gotta split it.
just do it to the last one.
This is because people don't charge their Chromebook.
I did charge my Chromebook.
Okay,
You
so
expect mine.
Because mine's at 45%.
okay. Ready, Sophie? Dylan? Okay, the graham crackers. What did the graham crackers show us, Dylan?
They form mountains.
They form mountains by what? Slowly. They form mountains slowly. Sophie?
So if you put watermelon, if you push it together, it forms like mountains and
Okay. Ledger?
so when you dipped it in water and pushed it together, it would slowly start to create like a mountain.
Good. The tectonic plates
What did you
push, typing, writing.
Very good.
Okay, the tectonic plates push together slowly and create mountains. Because the land just keeps pushing up against each other and it just goes. It literally goes like that. It goes.
Anybody and then saw them get made? Scientists? No, because it's so slow. Because the tectonic plates move like
super slowly,
10
right?
meters every like year. Nobody can set up a camera for 10 years.
You would die.
No, because it's a satellite. Satellites have like a
No, they don't.
Yeah,
They're powered by the sun.
have to go at like every year.
Okay,
To like.
ready to go on to the next slide?
No.
Yes.
They're powered by the sun.
Thank you, Dallas, for being ready. Run it, Leon.
I just like
What?
think that astronauts that are in space just mess it
Oh,
around.
Thank you for getting up better and
Okay.
I bet they're like just Mars and find a vaccine. They go to the sun, they find the vaccine, a little vial, and it says vaccine. Because they go back to they come alone to Earth. They're like, how is it?
I don't know. It might just have to do with their battery. Okay, let you know already. All right. These models show us tectonic plates could move and how they might move. But what evidence do we have that they actually move? Let's explore that question today, okay? So we can't say mountains are built up because graham crackers smush together and build mountains. That's not actual scientific evidence, okay? So let's look at the map on the next slide and think about how it relates to our egg model of the Earth. Okay? All right. Okay, so we're looking at our eggshell model of the Earth. Okay? Sophie, play your mask up. Thank you. Okay, so what are the red lines?
Where it used to be.
Where they used to be? Well, how do you think this looks like an eggshell compared to the red lines?
They fell off.
That's where they're cracked. It's kind of like where the boundaries are. Okay? Those are kind of like the different puzzle pieces, right? Okay, what do you think the black arrows indicate? Dylan?
The tectonic plates.
The tectonic plates doing what? Forming stuff. The tectonic plates, how they're moving. Shh, focus. The tectonic plates, which way they are moving, right? Okay. So the red lines are the plate boundaries. It kind of looks like when you boil an egg and you crack it. They kind of have some sharp edges, some long pieces, some smaller pieces, and it's kind of like a puzzle piece. Okay, ready, boys? Okay, so how many plates do you see on here?
1, 2, 3, 4, 5, 6.
1, 2,
3, 4, 5, 6, 7, 8, 9,
4,
10. Mine disappeared.
5. Oops.
Miss Tapia, one of my writing things disappeared. Miss Tapia.
Oops, that's okay.
You need to do it proper. It's back. There's 12 at the top. 12? There's 12? Yeah. She's here. Just click on it.
I count 18.
How did you do in specials?
Where did it go?
We were there, Thomas. You were such a baby for
With Marlene, that's none of your business, okay?
I'll say.
I probably got all 1, 0, 0.
Not all ones.
Yeah, let's try to
Oops.
Now I got 1.
Ready, Freddies? Okay, so I stopped at 12, 13, Ledger Noah, 14,
You know how a lot of people go like
15, Dylan, 16, 17, Ledger, 18, 19.
There's a small
20?
little hidden
this
one.
20, this 20.
I don't know if I would count the edges ones as two different ones, because remember the earth is not flat, it's all connected.
It's flat.
So there's about 20.
It's, the earth is pretty.
Okay,
It's a triangle.
ready.
Oh no.
So last time we talked about what happens when tectonic plates collide together. So what did we think might happen when they collided together? Do you remember what, Sophie, put that down.
No, look. There's another picture.
What did we say? Do you remember? What did we think might happen? Oh, my turn. I will not bring treats next time.
I think we're going.
Okay, do you remember what we said that we think might happen when tectonic plates collide? What did everybody say?
Volcanoes.
Yeah, most of you said volcanoes
Earthquakes, tornadoes,
creates
hurricanes.
volcanoes and earthquakes. Elian, Chromebook on your desk, please.
Why does it say create?
Because I wrote this first and then I realized I needed more.
Did we skip page 8?
First page 8.
Oh, because look. Yeah, I have a page.
That is
in here.
That's page 7.
The tectonic plates create volcanoes, and then volcanoes create islands. This is page 1. Hers is different.
Keep it in your head.
Okay.
Okay. Creates volcanoes and earthquakes. That's what you said last time. Elian, turn around. Elian, aquí. Volteese. Gracias. Got it, Sophie? Okay. Look at the map again and see where you think these plates might be colliding. Mark those places on your map with an X. So go to insert, go to shape, and then go to equations. And it'll show you like a big X, and you can move it around on the picture. Or you can copy and paste this one. So click on it with 2 fingers, put your mouse cursor over, click on it with 2 fingers, and then the little drop menu will show, and you can click copy.
What did we move the?
Okay, do you want me to show you?
Oh, where?
Okay, so you'll click 2 fingers, put your cursor over it, click on it with 2 fingers, copy, go on to the slide before. So you're going to put on here where you think that plates might be colliding. So you're going to have to look closely at the arrows, right? Okay, so I see, let me come over here. So I see right here, these 2 arrows are showing that they're going this way.
I can't move.
So if they keep going this way, they're going to collide, right?
I can't move my X there. I can't either.
So okay, then go to equations. Sorry, insert.
Where's your CTRL? Guys, just click Control V. Oh, yeah.
Why can't I find it?
V, where do we put the X?
Shape.
Where do we put the X? Where two tectonic plates.
Where they are colliding. Where the tectonic plates are colliding. So this is your student one. Okay, so insert. That's how I've done it before. Why isn't it showing? Insert, shape. Oh, here's equation. My God. Okay, and then here's the X. Okay?
I did it.
Dylan.
I wish I could. Look, how do you do it? Since I ate that apple. Sorry. Miss Katya, since I ate that tape, time went by flying.
Okay, did you find how to do it? Elian, tapa boca. So insert.
Not everybody.
So you should be on this page.
Or you can just hit
Dylan, you need to use your pencil, so you need to be on this
or
one.
you can click copy and
Insert,
then go to the page and press copy.
insert,
Not Z.
shape, equation. Here's an X.
You don't need to do insert.
So you click on it, and it'll pop up, and you can.
Click on the circle and the square.
Ah! Where did it go? Ah! That's a big one.
I did it.
So then you'll click on it and drag it over right there. Okay? So, on mine, so here are two tectonic plates pushing against each other. Ledger, turn around. So X here. Are these colliding?
Yes.
No, they're not. They're pushing away. They're going away from each other.
No, they're not.
Are these colliding?
Yeah. Yes.
Wait, are we supposed to put
Are
on?
these colliding?
Are we no.
Yes, Marley. Yes.
Wait, what does that
Are these colliding?
Yes. No.
No. Are these colliding?
No. Yes. Yes.
Yes. You need to have multiple X's, not just one. Keep going. Put that away.
Wait.
There are multiple ones colliding. Are these colliding?
Why aren't these ones
Which one?
Those
This one?
Wait, no, Miss Katya,
that one?
that you
Yeah.
did, they're
That
not
one is.
colliding. Oh, I almost one. Miss Katya, that one's not colliding, they're parallel.
What do you mean?
Wait a second.
They're not like going in the same direction, they're going like parallel.
These ones are going parallel.
Oh,
These ones are colliding.
it looks like they're just going like, they're both
The
going.
arrow, okay, so the arrow's not perfectly aligned,
One's
but
slightly
yes.
like this.
These ones are parallel. They're going this way. So they're shifting this way.
Yeah, I got all of them.
These ones, are they colliding?
Yes.
Okay, put an X there. Elian,
I already got the ones
are these ones colliding? Okay, are these ones colliding?
Yes. Yes.
Yes.
I have like 50 X's on my
Are these ones colliding?
Yes.
I don't remember if I asked you that.
And yes.
Are these ones colliding?
No.
Okay, these ones?
No.
These ones?
No.
These ones?
No.
These ones? These ones? These ones?
No.
These ones?
Yes.
These ones?
No.
Is that all of them? Okay, so you should have 1, 2, 3, 4, 5, 6, 7, 8, 9.
1, 2, 3, 4, 5, 6, 7, 8. Oh, shoot. Oh, 1 and 9.
Okay, so quickly double check that you have 9 of them. Thomas, I need you to do it on your paper. On your paper. Thank you.
I only have 8.
Make sure you have 9.
I have 9.
Okay, next slide. Ready?
Which is the 9th one? Do you know where it is? Look up on the
Hello. That's okay. Do you want to just bring them on their, put them on their desk?
Yeah.
Okay, thank you.
Yes.
Okay, Noah, ready? Ready? Okay, next slide. Try to imagine a collision. Dylan, Elian, focus. Elian. Dylan, between two plates, two huge pieces of land. So do you think that it's possible for the solid rock that forms Earth's crust to bend and break and get pushed up into mountain ranges like the crumbled up graham crackers? So what do you think? You think yes or no? Yes? Okay. Can you predict where we might see these mountain ranges on our map? Close it. Thank you, Ariana, for having my attention. Thank you, Thomas, for focusing up here. Thank you, Emma. Thank you, Dylan. Okay, so where do you think we might find these? What do you think? Do we have some like these in Utah?
No. Yeah, the